Hello, welcome back to the channel. In this video, I am going to focus on Cambridge International A-Level Physics, Paper 5, Planning, Analysis, and Evaluation paper. So this is October-November 2024, paper 52. So I have a very super duper important tip that I will share at the end of this video. So I hope all of you can stay until the end of the video for that very super duper important tips in answering paper 5. So please stay tuned. So are you ready? Let us get started. Look at the first question. Wow. Fig 1.1 shows a coil made from resistance wire. The coil is placed in cooking oil, not water, cooking oil of mass M. The total length of the resistant wire in the oil is L. A potential difference V is applied to the coil. Temperature of the oil increases by delta theta in time t. It is suggested that delta theta is related to L by the relationship given here, where A is the cross-sectional area of the wire and K and Z are the constants. Plan a laboratory experiment to test the relationship between delta theta and L. So you have to focus on delta theta and L. Draw a diagram to show the arrangement of your equipment, which I already draw and I'm going to show you later. Explain how the results could be used to determine the values for K and Z. And in your plan, you should include the procedure, the method to be followed, the measurements to be taken, the control variables, the analysis of the data, any safety precautions to be taken as well. Now, when you first see this kind of question, right, first thing you do is focus on the relationship suggested. So since this experiment is about the relationship between delta theta and L, so you have to focus on making one of these two as your independent variable. You know, how do we determine the independent variable? Independent variable is actually is up to you, but the easiest way to determine which is your independent variable is you ask yourself, okay, check between delta theta, which is the change in temperature, because it is the increment of the temperature of the oil. Is it very easy to alter? Because, you know, when you talk about delta theta, increase in temperature. So when you talk about the increase in temperature, don't you think that you need initial temperature, you need final temperature, and you need to find the difference between the two? For me, I think that that's a lot of hard work because I have to make sure that, oh, this is independent. This is the initial temperature, and I have to make sure that that's the final temperature. I find the difference between the two temperatures. So it is a lot of workings for me, workings for me. So I prefer shortcut, right? Where look at L. L is just the length of the resistant wire in the coil. So it is very easy for me to alter. It's very easy for me to modify the length. If I want this length, then I cut to this length. If I want the length to be longer, so I use a longer length. So it's easier, save the time. So that is why I am going to make my L as my independent variable, right? So, and my delta theta will be my dependent variable, right? But I'm going to modify the equation first, right? Just to see what kind of graph that I'm supposed to plot, right? And because I have to determine the values of k and z, so of course I need to relate to the gradient of the graph. I have to relate to the y-intercept of the graph. This is all about math, right? Let us do a little bit of math here. How about that? Right, so I'm going to write down the equation. This is atv square. So I'm going to modify a little bit. I put atv square and then I put 1 over L just right here is equal to mk delta theta plus z. Right, and then 1 over L seem to be a little bit of, I don't like to put division, right, as my y-axis. So I want to put delta theta as my y-axis. So I switch the position. Mk delta theta plus z is equal to ATV square 1 over L. And then I make delta Mk delta theta, which I switch A T. This is T, not plus, yeah? Okay, this is T. V square, potential difference, minus the Z, and then make delta theta as the subject, AT V square divided by MK times 1 over L. I still want to put 1 over L there, and minus Z over MK. So tada, this is the equation that I have already modified. So I am definitely going to use this equation and then, right, to plan my experiment. Right now, this is my diagram. Right, my diagram, because I have to measure the potential difference. The potential difference is included in our calculation right here. So I need to have a voltmeter to measure the potential difference. And then I have a variable resistor as a safety precaution because I want my variable resistor, the function of the variable resistor is to control the amount of the current that flowing through the coil of the wire. I don't want my wire to be melted and too much of the current to flow through it. And I have connecting LEDs or connecting wires, which I connect to the power supply unit. And I have a thermometer, and of course thermometer because I want to make sure that I measure the initial and the final temperature. And then, of course, this is a coil of the wire. Could you see that? This is a coil of the wire. And this is a cooking oil. Okay, this is a cooking oil inside the beaker right there. And since the cooking oil, right, is a liquid, so that is why I want to use a stirrer as a safety precaution as well, because I want to make sure that the heat right from the wire is being distributed evenly throughout the cooking oil. And I want to minimize the heat that lost to the surrounding. Of course, I cannot use a lead because connecting the coil is inside there. And how am I supposed to close the surface of the beaker, right? The upper surface of the beaker. So I will leave it that way. But I just want to control. I just want to minimize the heat. So that is why I use a felt jacket. Felt jacket is actually an insulator surround the beaker to just minimize a little bit that heat loss to the surrounding. Right, of course, my independent variable, I choose L as my independent variable. Like what I say, because it is very easy to vary. It is very easy to change the value. And my dependent variable, of course, will be delta theta. And everything else that's stated in the equations will be the variables to be kept constant. So please make sure that you write more than one because this is variables. It means plural. So I put T, I put potential difference, I put maybe thickness of coil. And maybe I put, because the coil itself, okay, consists of a number of turns. So number of turns of coil and M itself, the mass of the cooking oil. Now let us talk about those are the variables to be kept constant. If feel free to pause the video if you want to write the answer. So my method, first one, I always start with set up the apparatus, be polite, set up apparatus as shown in diagram. And of course, I focus on the independent variable. You have to tell us, right? Since we are the planner, so we have to tell that how are we going to vary L? How are we going to measure L? That's all. So I put L because L has already been explained in the question itself. So I know I don't have to rewrite L, right? Save the time. L is measured by using a meter rule. I use a meter rule to measure the L. And after that, third method, I say because I also need to make sure that my variables to be kept constant, which is the mass of the oil, must be measured as well. Or else, how do I do my calculation, right? M is measured by using electronic balance, which is more accurate, right? Because this is digital. And then I said that I'll take the initial temperature of the oil first. Initial temperature of oil is taken by thermometer. I put this as theta 1 symbol. And then after that, I said that I turn on power supply and I want to make sure power supply is turned on at 2.0 volt. Just give a value. And yeah. And after maybe I use my stopwatch. Okay, after maybe 3 minutes, you can give your suggestion. Or you say after 5 minutes, it's up to you. The time is actually up to you. Right, I said that final temperature of oil is taken by thermometer. Okay, I put theta 2. And then time is measured by a stopwatch. And then I said that delta theta, I don't have to explain every symbol here because I have already explained theta 2 minus theta 1. And after that, okay, before I end my procedure or method, oh, this is number 9, I would say that experiment is repeated. So always end with experiment repeated with different values of L. That's it. And I'm done with that. So I am going to move on to my analysis after that. Analysis Analysis, remember for analysis, the mark given is 3 marks. So you have to write at least 3 points. So the first analysis I told you, okay, I'm going to talk about the graph. A graph of delta theta. So remember, let me scroll out a little bit. You can see my equation. Delta theta against 1 over L is being plotted, right? Delta theta against 1 over L is plotted. That's it. And the second part, okay, this is a straight line graph. Yes, this is 100% a straight line graph because it fulfills the straight line equation. This is y, this is x, this is m, and this is y-intercept. Could you see that? So this is the straight line equation. So you have to tell the examiner that this is a straight line equation with y-intercept. So I say that if a straight line graph with y-intercept of, okay, let us look at y-intercept. Let me scroll out a little bit. Negative z over mk. Remember that, okay? So negative z over mk, right, is obtained. If you want to give the value of the gradient, it's also okay. I mean, not the value of the gradient, okay? What is the gradient? Oh, is also okay. So I will say that relationship is valid. That's all. And the third one, okay, so remember the question asks us to find something, right? Explain how your results could be used to determine the values for K and for Z. So I would say that, okay, y-intercept, I'll show you the working right here, is equal to negative Z over MK. That is why oh, this is M, this is K. Never mind, I do for my gradient first. Gradient is equal to A plus V square, ATV square over MK. So let me show you one more time. ATV square over MK, that is the gradient, right? So that is the I'm going to scroll down right here. ATV square is the gradient over MK is the gradient. That is why you make K as the subject. Cross multiplication ATV square over gradient multiplies by M. That is your K value. Wow, things are very complicated, don't you think so? So I shift this negative first. Negative y-intercept is equal to z over M. Wow, okay. And the K value is ATV square over gradient multiplies by M. I want you to see this right here. Now I use different colors so that you can see it clearer. M and M can be cancelled. That is why your Z right here is equal to negative y-intercept multiplies by ATV square over gradient. Ta-da! We get the value. We have already answered the question, right? Now, the last part is about additional detail and your safety precaution. Let me write it down. Details and safety precaution. You can see from the diagram that I drew right here, safety precaution, sorry. Okay, you can see the diagram that I drew right here. I have two safety precautions. One is variable resistor to make sure that I can control the amount of current that flows through the coil. And I also have the stirrer to make sure that even heat is being distributed throughout the cooking oil, right? So, and the felt jacket, one more, to just minimize the heat that lost to the surrounding, right? But still, I need to write down something as well. So I say, okay, I call it as rheostat, or you can call it, or since I wrote that variable resistor, I better call it as variable resistor as well. I don't want to confuse you. So variable resistor, or it can be called as rheostat as well, yeah, is used to control amount of current flows through coil. That's it. And then I also have for the potential difference, because I know that the specific heat capacity of the oil is quite small, so we just need a little bit of heat to heat it up, right? So I say I use a small value of voltage. Uh, Let me write this down, of voltage. Okay, 2 volt that I use is used as oil has small specific heat capacity. And I also say that I use a large beaker is used to fill the oil to prevent spillage of oil, right? And then I also say that the number of turns of the wire, I use N number of turns of coil use is maybe 30 turns to reduce the percentage uncertainty, to reduce percentage uncertainty of delta theta, the change in temperature, because if I use more turn, the change in the temperature could be larger. right? And then I also say, because I want to keep the thickness of the coil as one of the variables to be kept constant, right? So that is why I have to talk about that in details. How do I keep that constant, right? So I say micrometer, screw gauge is used to measure diameter of coil, and measurements measurements are repeated along the coil and average. You know why? Because when a coil or the wire, before it is made into the coil, right? The wire itself is not 100% straight. So they come with a crooked. Some part of the area, some part of the coils are crooked. The wire is actually crooked. We call it as kinks, Kinks. So that is why when we make it into the coil, right? If you only measure at one position, right, that will give rise to a large uncertainty. So we find the average, but we don't repeat at one point, but we will repeat along the coil or along the wire and find the average, right? And I also say that how that I calculate the surface cross-sectional area of the coil. A is equal to pi d squared over 4, right? Where A is the cross section of coil and D is the diameter that I have already measured. Right, and then I also say that if I want to, this is number 7, sorry, and I also say that if I want to measure, right, I use electronic balance to measure the mass of the oil, but the oil itself has to place inside the beaker, right? So I talk about that. Mass of oil is equal to mass of oil plus beaker minus mass of beaker or empty beaker, right? So that is all about my safety precautions and additional details, right? You need to give at least 6 points for that 6 marks over there, right? Now, question number 2. A student investigates the refraction of white light entering a transparent rectangular block. A narrow beam of light enters the block at the midpoint of one of the shorter sides. The angle of incidence theta is measured as shown in Fig 2.1. The distance d between the corner of the block and the point where the beam of light touches the boundary of the block is measured. Experiment is repeated for different values of theta, and it is suggested that d and theta are related by the equation given where b and n are constant. And a graph is plotted of d square on the y-axis, so you have to make sure that y-axis is your d square against 1 over sine squared theta on the x-axis. Determine expressions for the gradient and y-intercept. Now we need to modify this equation, right? And I need that d squared on my y-axis. So I do my cross multiplication. B plus d squared sine squared theta is equal to bn squared. Cross multiply, and then I shift away sine squared theta to the other side. B plus d squared is equal to bn squared over sine squared theta. And then I make my d squared as the subject is equal to bn squared, right? Over sine squared theta minus b. So ta-da, I got it. And then how am I going to modify that? Don't you think that this is your y-axis? Okay, I modified that. Okay, before that, let me modify this a little bit. Okay, so I have d squared is equal to bn squared times 1 over sine squared theta minus b. So could you see right here? Could you see right here? This is your y-axis, this is your x-axis. So don't you think that the gradient is quite obvious, which is bn squared, and your y-intercept is negative b. That's it, to get that 1 mark. Now, values of theta, 1 over sine squared theta and d are given in the table 2.1. Calculate and record values of d squared per slash cm squared, that's the unit of d squared, in table 2.1. Include the absolute uncertainties in d squared. Now, if you want everything to be easier for you, I am following the ones that you have learned in AS, which absolute uncertainty can only take one significant figure. Right. So I'm going to put plus minus in between first. Everything plus minus first. First thing, calculate the absolute uncertainty of d squared. Now, how do we calculate delta d squared first? You see, the value of d is being given. So look at the first value, 24.8 plus minus 0.2. So that means 24.8 is the average values between the two extremes. You plus 0.2 and you take 24.8 minus 0.2. But I only want you to consider, right, plus 0.2 because I don't want to take my absolute uncertainty to divide by 2. That will be too much of the work. Right, so each and every time when you see plus minus, you take 24.8 plus 0.2, you get another, okay, upper extreme value, which is 25. Right, so to find delta d squared for the first one, delta d squared for the first one, you take 25, the upper extreme value, the largest one, minus the average value. So you don't have to divide by 2. So round it off to 1 SF because like what I told you, I want to follow AS syllabus. AS physics states that the absolute uncertainty can only take 1 SF. So I round it off to the nearest 10, which is 10. I got 9.9 something. So I round it off to the nearest 10. Now, the next value for the next d square value, this is 21.4 plus 0.2, you should get 21.6. So delta d square right here, I use 21.6 square minus 21.4, you square it. Right, round it off to the one significant figure. So I got 9. So I put 9 right here. And the third one, 17.1 plus 0.2, the upper value is 17.3. So delta d square, I take 17.3 square. I'm so sorry, 17.3. Let me write it down. 17.3 you square minus 17.1 square. Put it in terms of 1SF, I got 7. And the next one, 14.7 plus 0.2. This is 14.9. So that is why delta d square is equal to 14.9 square minus 14.7 square. Round it off to 1 SF, I got 6. The next one, 12.9 plus 0.2, that's 13.1. So that is why delta d square is 13.1 square minus 12.9 square. Round it off to 1 SF, I got 5. And the last one, 11.8 plus 0.2, I got 12. So that is why delta d square is equal to 12 square minus 11.8 square. Round it off to 1 SF, you got 5. And after that, to find the d square value, bear this in mind. D square value must follow the decimal point of the absolute uncertainty of its absolute uncertainty. So you take 24.8, you square it. Since for the first D value, I round it off to the nearest 10, right? Let me use my calculator for 24.8, you square it. You're supposed to get 615.04, right? For the first value, 615.04. But since the first absolute uncertainty, I round it off to the nearest 10. That is why this D value, I would round it off to the nearest 10 as well, which is 620. Without any decimal point, because my absolute uncertainty of D squared has no decimal point. Right, so the next value, 21.4, you square it, right? And then round it off to the nearest whole number, right? 21.4, you square it. I got 458. because the second value, I did not round it off to the nearest 10. So this one, okay, for the second value, all you need to do is just to make sure you round it off to the nearest whole number, right? Close of three significant figures, 4, 5, 8, right? And then 17.1, you square it, I get 292 without decimal point. Round it off to not get any decimal point. 14.7, right? You square it, you get 216. And then 12.9, round it off, you get 166. And then 11.8, you round it off, you get 139. That's it, right? We are done with the table. And then C, part 1, you have to plot a graph of d squared against 1 over sine squared theta. And you have to include your error bars for d squared as well. So first of all, before you plot your graph, right, of course, you have to make sure that all the points are being plotted on the straight line graph and the straight line graph is being drawn. Since I draw it digitally, the graph that I drew right on the screen right now might not be very accurate as the one that you drew, you draw on your paper. So I teach you how to draw the best fit line right now. If you want to get, right, if you are unsure which is supposed to be your best fit line, is this best fit line or is that your best fit line? I give you one tip right here. Now you look at your x-axis, y-axis, d square, right? Look at your d square value, 620, 458, 292, 216, 166, 139, right? So what are you supposed to do right now is that, my suggestion is that you add out 620 plus 458 plus 292 plus 216 plus 166 plus 139 divided by 6. Find the average coordinate of your x and y axis. Right? So my y-axis, okay, so I just add it up. Okay, 620 plus 458 plus 292 plus 216 plus 166 plus 139 divided by 1, 2, 3, 4, 5, 6 divided by 6. Okay, I deleted. Give me a while. 458 plus 292 plus 216 plus 166 plus 139 divided by 6, and I got 315. Okay, I just write it down here. 315 y-axis, and x-axis is 1 over sine square, so 4.39 plus 3.28 plus 2.19 plus 1.7 plus 1.41 plus 1.25 and divided by 6, and I got 2.37. Okay, once you get this coordinate, right, this is called the centroid. Centroid. Okay, I write it down. Centroid. I write it down at the side here. My centroid is 2.37 and 315. 315. This is the centroid, is a coordinate, is the average coordinate that a straight line must pass through, right? So whenever you draw, refer to this centroid, right? The one that I plotted here might not be very accurate, right? I hope you understand drawing digitally is never my thing, right? Okay, so but okay, once you have drawn your best fit line, and then you include your error bars. Error bars is your y-axis error bar, so it has to form a straight line like this. Okay, it is called vertical error bars. So vertical error bars, how do you see it? You look at, okay, the first error bar, 4.39. I think this is the last point, right here. Look at this last point right here. Right, this is 10, right? So you look at the smallest value, okay, on one of the small box there. Look at the y-axis only, right? So it is 5. So 5, that means when you plot a point, this is a point, right? Going up, this is 10. That means 2 boxes, because one small little box is 5. 2 boxes, and then going down, 2 boxes, 2 small boxes. Going out, 2 square as well. Squares. Are you square? I hope you understand. 2 square. 2 square, upper 2 square from the center of the x itself that you plot, upper 2 square, lower 2 square to get 10. Right? And then the rest, okay, for 9, okay, just roughly see, right? It has to be more than 5, more than 1 square, but lesser than the second square. That is 9. Okay, and 7, 6, 5, and 5. So you can plot all these. And before you plot your worst fit line, because the second part, they ask you to draw a line of best fit and a worst acceptable straight line on your graph. Worst acceptable straight line, bear in mind, this is your, okay, first point, okay, first error bar and the last error bar. Okay, you just focus on the first error bar and the last error bar. You want to draw your worst acceptable straight line. Look at first error bar and last error bar. If you start from the top of the first error bar, you have to stop at the bottom of the last error bar. But make sure that the worst fit line that you draw must cut through all the error bars in between. On the other hand, if you start from the bottom of the first error bar, you have to stop at the top of the last error bar. And also same thing, make sure that your worst fit line passes through all the error bars in between. That's it, right? That's it. And 5, determine the gradient of the line of best fit and include the absolute uncertainty. If the question asks you to include the absolute uncertainty, you have to use your best fit line and worst fit line. Right, so I get the gradient for the worst fit line. This is my worst fit line. This is my 2 coordinates, and this is my best fit line here, and this is my coordinate. Right, so I am going to use that. So the best fit line, I'm going to use 2 coordinates. One is 1.05110, and the other one is 4.5 and 640. Right, 2 coordinates to find the gradient. So gradient, I put best fit. So I put MB, M best. That means the gradient of best fit. So Y2 minus Y1 divided by X2 divided by X2 minus X1. So I take 640 minus 110 divided by 4.5 minus 1.05. Right? So I get 153.623. It doesn't matter how many significant figures that I put in because this is not my final answer. This is just my intermediate answer. And for the worst fit line, I get my worst fit line and worst gradient of the worst fit. So you depend on the worst fit only. So the worst fit line, my gradient, my 2 coordinates are 4.5 and 625. And the other one is 1.5 and 180. So I'm going to do my calculation right now. So it is equal to 625 minus 180 divided by 4.5 minus 1.5. So I got 148.33. So to find the absolute uncertainty of the gradient, so you take the bigger value of the gradient minus the smaller value of gradient and put it in terms of one significant figure. So I take 153.623 minus 148.33 and put it in terms of one significant figure, I get 5. So I put plus minus 5, and then the value of the gradient. You have to use your best fit and follow the reading of the gradient must follow the decimal point of the absolute uncertainty of the gradient. Since the absolute uncertainty of the gradient has no decimal point, so I round it off to 154 as the value of my gradient. That's it. And determine the y-intercept of the line of best fit, include the absolute uncertainty in your answer. Now, I'm so sorry to tell you that you cannot read out from the graph. You know why? Because your y-axis does not start from 0. Unless your y-axis itself start from 0, then you can take that as your y-intercept. Right? So if we can read off from the graph, what are we supposed to do? We are supposed to do substitution. What is substitution? Substitution is that you look at the graph that you plotted. This is a straight line graph. Straight line graph, the general equation of the straight line graph is mx plus c. Right? So for best fit, I'm going to write down best fit first. I'm going to use the 2 coordinates. Right? I'm going to use the coordinate from the best fit. So I take 4.5 and 640 here. So it is up to you as long as the coordinate is taken from the best fit line. So I take 4.5 and 640. Right, so y is 640 gradient. I have already calculated the gradient just now, right? So I take the intermediate answer, the gradient of best fit, which is 153.623. Right, one. If you want to take the round off answer, it doesn't matter as well. 623, and then x-axis is 4.5, and plus C best, right? Y-intercept of the best speed. So the y-intercept of the best speed that I got is negative 51.3. Wow, negative, right? For the worst speed, I use the same thing, but it's just that the coordinate is taken from the worst fit line. So the coordinate that I take from the worst fit line is 4.5 and 625, right? So I take 4.5 and 625, right? So my y-axis is 625. Gradient of the worst fit is, I take the intermediate answer, 148.33. So I put 148.33, and then the x-axis is 4.5, and C worst, y-intercept of the worst fit. So I got negative 42.5. So delta C, you just take anything, negative 42.5 minus negative 51.3. So round it off to 1SF because I prefer to put my absolute uncertainty in one significant figure. So I round it off to 9. Plus minus 9 and write down because y-intercept has no decimal point. So I round off my y-intercept of the best fit. So I get negative 51 plus minus 9. D part 1, using your answers to A, C part 3, and part 4, determine the values of B and N, include appropriate units. Beware. So, look at the first part, right? You know, I do the y-intercept first. You know why? Because the gradient includes B and N. Y-intercept is only about B, right? So I write down my y-intercept. Y-intercept is equal to negative B. Since the question did not ask me to include the absolute uncertainty for B, so I'll just write down y-intercept is negative 51 is equal to negative B, so B is equal to 51. And what is the unit of B? Y-intercept, you just look at the graph. What is the unit of y-axis? cm squared. So B is cm squared. 51 cm squared, that's B, right? And you know that the gradient is equal to Bn squared, right? So the value of the gradient, I would like to round it off. It doesn't matter. You round it off to 154, it doesn't matter. Doesn't matter. 154, let me write it down nicely. 154 is equal to B, which is 51. Sub in 51. Sub in 51. 51 times n squared. So my n would be equal to 154 divided by 51 and square root the answer. So I got 1.74. I put it in terms of 2 to 3 significant figures. But what about the unit of n, right? So n is the square root of, okay, let me write it down. Okay, gradient, I write down the gradient first. Gradient is y divided by x. X has no unit, but y is the unit of cm squared. Can you see that? So gradient is cm squared is equal to b is cm squared as well. And okay, b, the unit of b is cm squared, so times the n squared. So that is why n squared is equal to cm squared divided by cm squared. So n is equal to no unit. So I just put 1.74. That's it. Now, determine the percentage uncertainty in n. Wow, so I need, because the n here that I calculated, I use the best fit. Right? Best fit gradient, best fit B to do my calculation. So that is why, okay, the other way to do it is that I find the worst fit because gradient, okay, let me erase this. I use worst fit first because I don't have delta n. So I've used the worst fit line. worst fit line. I have a gradient. Okay, m worst is equal to b worst times n squared. Worst, right? So m worst is, I rounded off to 148, and the b worst is actually here. B worst is the worst y-intercept, 42.5. Right, so I just put 42.5 times the n worst. I square it, so I get n worst, which is 148 divided by 42.5, and you square root it, and I got 1.86. Now to find delta n, I type 1.86 larger n minus the smaller n, and worst minus n of best fit, 1.74, and I got 0.12. So the percentage uncertainty of n is delta n over n times 100%. Delta n is 0.1. I round it off to 0.1, okay? Divided by n value. This n value must be the n of best fit times 100%. And do you still remember in the AS that you learned that the percentage uncertainty can take 1 to 2 significant figures only? So I'm going to put in terms of 1 to 2 significant figure, which is 6.9%. 6.9% is the answer. And the last part, the experiment is repeated. Determine the angle theta that gives a value of D of 30 cm. The last question, normally you have to use the whole equations that is being suggested. So the whole equation is actually right here. I'm going to use this. D squared is equal to bn squared times 1 over sine squared theta minus b. So I'm going to use that. Let me write it down. D squared is equal to bn squared 1 over sine squared theta minus b. And since they did not ask to include any absolute uncertainty, I'm going to use the best fit value. And I'm not going to change that cm to meter, right? So this is 30, you square it. B, the best fit is 51. And n is, the best fit is 1.74, you square it, times 1 over sine squared theta minus 51. Now, okay, I shift everything. 30 squared plus 51 divided by 51 times 1.74, you square it, is equal to 1 over sine squared theta. Sine 1 over sine squared theta, when you do your calculation, I got 6.159. So I make sine theta square. Sine squared theta is 0.1624. That is why my theta is equal to 23.76, which I rounded off to 24 degrees. So my answer for theta is 24 degrees, right? That's the end of our discussion. Right, do you still remember at the beginning of the discussion, I told you that I would like to give you a very, very important tip here for paper 5. It is valid to all paper 5 actually, right? So the tip is that whenever you receive your paper 5, first thing you do, ignore the first question first, because you are given 1 hour and 15 minutes to answer the whole question. So I suggest you to turn on to the second question first, right? Turn on to the second question and answer the second question, because second question basically is more on calculation. So you have to do more practices and finish answering the second question within 20 to 25 minutes. And the rest of the time will go to question number 1. Because question number 1, you need to think. Sometimes when you think too much, it would eat up a lot of your times, and you might not be able to finish in time. So that is the tip that I want you to remember. So that's the end of the video. I hope that all of you gain benefits. And if you face any hesitation, any problem, if you want the answer, you could comment below. And thank you very much for watching. Oh, and I'll see you in my next video. Bye.